In this video, I'm now going to start showing you how to solve quadratic equations using the quadratic formula. So there's our quadratic formula right here. There we go. And there we go. This. Okay, so in order to use the quadratic formula, first of all, you have to identify A, B, and C. But you can only identify what A, B, and C is after the equation is already set equal to 0. And that is simply not the case in this first example. So in this example, let me slide this up here. You can see that I have my ax squared plus my bx on one side, but my c term is actually on the wrong side. So I'm going to have to fix that by subtracting the 6 from both sides. So I'll have 4x squared plus 5x minus 6 equals 0. And now it's in the right form. It's in the form of ax squared plus bx plus c equals 0. And now I can identify my a, b, and c. So my a is 4, that's the coefficient of the x squared term. My b is 5, that's the coefficient of the x term. And my c is the constant term, which is a negative 6. Really be careful with your signs because they make a huge difference, as they do in every area of mathematics. They make a huge difference with these quadratics as well. So I've written down my quadratic formula, but I also want to remind you that there are some implied parentheses that we just need to make sure that we're paying attention to. So we're going to be taking the opposite of whatever b is. Then we're going to be squaring whatever b is. Then we're also going to make sure that we are keeping track of the fact that this radical has implied parentheses inside of it. And then we have to keep track of the fact that there are implied parentheses around the whole numerator and around the whole denominator. I'm going to pull those out of here in a minute, but I want to make sure that I at least mention it at the very start. So let me get rid of those now so that they are not in our way. Okay, so when I substitute in, here's what it's going to look like. I'm going to have x equals. Now, the opposite of b means the opposite of 5, plus or minus the the square root of the b, which is 5 being squared, minus 4 times the a, which is 4, times the c, which is negative 6. And then all of that has to get divided by the 2 times the a, which is the 2 times 4. Everything else I do now is really just following order of operations. So this is old stuff at this point. So the opposite 5 is negative 5. Inside of my radical, 5 squared means 5 times 5, that's 25. And by the way, regardless of whether the b is a positive number or a negative number, anytime you square any kind of number, you always get a positive result, except for 0, of course. Okay? In the back, just do these in order. Treat this as a negative 4 times a positive 4. That's a negative 16. And then take that negative 16 and multiply it by the negative 6. And that's going to give you a positive 96, right? You have 2 negatives here, so the answer will be positive. So 4 times 4 times 6 is 96. 2 negatives make it a positive. And then I'm dividing it all by 2 times 4, which is 8. Next, I am going to go ahead and do the addition in my radical. So 25 plus 96 is 121. And then that's going to get divided by 8. All right, where am I relative to the bottom of this first page? Pretty close. So I think I'm going to move this up now. Come up here. Give myself a little more space. So right now I have x equals, and then I have the negative 5 plus or minus, and it was the square root of 121, which is 11. And then all of it is supposed to get divided by the 8. I need to do each of these additions and subtractions in the numerator before I worry about dividing by the 8, because there are these implied parentheses around the numerator. Now, notice that -5 and positive and 11, positive or negative 11, are like terms, right? Neither one has a radical while the other one doesn't. Neither one has an I while the other one doesn't. So these are like terms, so I can definitely do both of these. So the first one, I'll split it this way, is we're going to do -5 plus 11 and divide it by 8. And the other one is we're going to do the -5 minus 11 and then divide it by 8. Okay, so here we have -5 plus 11 is 6, and 6/8 I can reduce to 3/4. So that's one of my solutions. And then over on this one, I have -5 minus 11, and that's -16 divided by 8. And -16 divided by 8 is -2. So I believe that those are the two solutions of this quadratic equation. As with any equation, you should always check your solutions. I'm just going to do so on my graphing calculator right now. Get rid of some of this stuff. So on my left-hand side, I'm going to check the 3/4 first. So my left-hand side is 4 times my x, which has to get squared. And then that's plus 5 times my x, which is 3/4. And that should give me 6, and it does. Now I have to check the -2. So I'm going to do the same thing. 4 times a -2, that has to get squared, plus 5 times a -2, and that should give me 6, and it does. So I am 100% certain that my two solutions here for that quadratic equation are correct. So there's our first one. Two more samples to show you here. And here's our next. Once again, you can see that in this quadratic equation, it is not in the right format. Remember, we have to have it in this format of ax squared plus bx plus c with a 0 on the other side of the equal sign. I like keeping my x squared term positive, so I'm going to move these terms to the left-hand side. And I can do that by, first of all, subtracting the 2 from both sides. So I will have x squared, and then I have -4 and -2 is -6 equals, this is gone, and I will have -4x. All right, then I'm going to have to add the 4x's to both sides. And there's no like term over there, so it'll be x squared plus 4x minus 6 equals 0. Okay, and now it is in the right format. So remember, the a is the coefficient of the x squared term. There is no coefficient, and so we assume that to be a 1. So my a is 1, my b is 4, and my c is -6. And what I have to do now is solve the quadratic equation by substituting these values of a, b, and c into my quadratic formula with all those implied parentheses that I was mentioning before. So we're going to do the opposite of our b, so that's the opposite of 4, plus or minus the square root of our b, which is 4, that has to get squared, minus 4 times our a, which is 1, times our c, which is -6, and all that has to get divided by 2 times our a, which is 1. The rest of this problem is making sure you follow the standard order of operations correctly. So I have -4 plus or minus, and now I want to show you a slightly different way to calculate the radicand, the part under the radical, right? You can do it in pieces following order of operations, or Actually, an easier way of doing it is to type the entire expression that's inside of the radical in at one time. So I'm going to type in parentheses 4 squared minus 4 times 1 times the negative 6. Notice I'm not typing in that square root radical because I just want to know what the radicand is, just the part under the radical, and it's 40. So you would get that if you followed order of operations, but it's much faster, and it checks, and it's a good way of checking yourself. Just make sure that you get that right radicand. So my radicand here is 40, and then this is all divided by 2 times 1, which is 2. Now 40, unlike 121, 40 is not a perfect square. In fact, the only perfect square factor that it contains other than 1 is 4. So I'm going to factor this, and I think I'm just going to kind of do it off to the side here, right? So square root of 40 is square root 4 times square root 10. This is 2. Square root 10 can't be simplified. Good. So that means what I have is x is equal to negative 4 plus or minus 2 square root 10 all over 2. Once again, I'm going to be looking for a little more space here. And so the first thing, I'm going to recopy this up here real quick. The first thing I notice is that unlike in example 1, where the two numbers that we had to add or subtract were like terms, right? Here, the two numbers that we have to add or subtract are not like terms. This one is just an integer. This one has a square root of 10 in it. That one doesn't. They don't have the same matching radical. Therefore, I cannot combine those two. So the last thing I can think about doing then is trying to simplify it as a fraction by dividing out any common factors that the numerator and the denominator share. So first of all, I'm going to have to see what my GCF is on the top, because that's where I have two terms. And I'm hoping you guys will recognize that the GCF up there is actually 2. And you can make it a positive 2 or a negative 2, to be frank. I'm just going to factor out a 2. I'm going to have 2 times. Now, I'm dividing each of these two terms on top by this 2. So negative 4 divided by 2 is negative 2. And then I have the plus or minus. And then I have the 2 square root 10 divided by 2 is just the square root of 10. So if I remultiplied this 2 out, I'd get back to that numerator again. And all that is divided by 2. And now that common factor of 2 can divide out. So my answers are x equals negative 2 plus or minus the square root of 10. And that's one way of writing them compactly. But you could also write them out separated by a comma, which is how the MyLab math program wants you to do it. So you just have one of them with the plus in between and the other one with the minus in between. Okay, and that's it. And we have one more example to go before I end this video. And once again, I'm not being very kind because once again, I am giving you an equation that is not in the right form, right? This equation is not in this form. It's not set equal to 0. I'm going to leave the 5x squared where it is, and I'm going to move these two terms to the left. And that's going to give me 5x squared minus 4x plus 3 equals 0. So my a is 5, my b is negative 4, and my c is 3. And now, so I'm solving this using the quadratic formula. Here is my quadratic formula, and all I have to do is substitute my values of a, b, and c in. So I get x equals the opposite of my b is negative 4. plus or minus the square root of my -4 that has to get squared. Minus 4 times my a, which is 5, times my c, which is 3. And all of that has to get divided by 2 times a, so that's 2 times 5. All right. The opposite of -4 is +4. All right, if you're going to do this by hand, this radicand, the part underneath the radical, if you're going to do that by hand, you better make sure that you get a +16 when you square that -4, because it is the b that is supposed to get squared here, right? And our b is -4. If I square a -4, it means I'm doing a -4 times another -4, and that's going to give me a +16. All right, then with these three numbers that I'm multiplying, one of them is negative, the other two are positive, so I know it's going to be a minus here. 4 times 5 is 20, and 20 times 3 is 60. And that's all over 2 times 5, which is 10. So inside of that radical, you should be getting a -44. Let's make sure of that on our calculator. So remember, inside of our radical, we had the -4 that was being squared. If you don't type in those parentheses, it's on you if you get it wrong. Times 5 times 3. Okay, -44. Okay, back to our lecture guide here. All right, once again, I have a radical here that I'm going to have to simplify. So I'm going to pull that off to the side and simplify that guy as well. So the square root of -44. Let me see here now. Well, first of all, I've got a square root of a -1 in there, right? So this is going to give me an I. 44 has a perfect square of 4 in it, and the other factor is 11. This is 2, so I have 2i times the square root of 11. That's how that simplifies. So back to my problem here. I think I'm going to bring it up to the top already. There we go. That's what I was trying to do. So I will have x equals 4 plus or minus, and then this is 2i times the square root of 11 all over 10. Once again, I try to do the addition and the subtraction that are indicated in that numerator, but I can't. Not only does this one have a radical that the front term doesn't have, but it's also imaginary. It has the imaginary unit I in it, and the front one does not either. So these are not like terms, so I cannot combine them. That means the best that I can hope for is that there is a GCF, or a common factor, that I can divide out between the top and the bottom. And it looks like there's a GCF on the top of 2 again. So I'm going to factor that 2 out. So 4 divided by 2 is 2. And 2i square root of 11 divided by 2 means the 2's will divide out. So I'll just have I times the square root of 11. And now I do have a common factor that I can divide out. 2 goes into itself once and into 10 5 times. So now my answers are 2 plus or minus I times the square root of 11. Now that's both, over 5, sorry. That's both of my answers in a condensed format. If I want to write them separated by a comma, like my lab math likes us to do, one is 2 plus I times the square root of 11, all divided by 5. The other is 2 minus I times the square root of 11, all divided by 5. That's an I, and that's an I. And there they all are, written out beautifully. Okay, That's where I'm going to end this video. That's how you use the quadratic formula. Have a great day.